Hello everyone, my name is Wyatt and I'm here with Blake Mullen on the podcast Wyatt's Guide to Cellular Respiration. Today we're going to be talking about cellular respiration. Blake, you're a bit of an expert on cellular respiration, isn't that right?
Yes.
Could you give us a basic idea of what that process is?
Cellular respiration is where glucose is broken down to make ATP.
But what is ATP?
ATP is energy which moves throughout the body.
Nice. So you said there were 3 steps, right?
Yes.
Can you tell us what those 3 steps are to start with?
Yes. Glycolysis is the step where a single glucose, which is carbon 6, is broken down into 2 molecules of pyruvate, which is carbon 3. And this is located in the cytoplasm. And it gives a net gain of 2 ATP and 2 NADH, which are electron carriers.
Okay, and then the second step is?
The Krebs cycle.
We can have a jump cut there.
Okay. The Krebs cycle, which is located in the mitochondrial matrix.
Wait, sorry, did you say crab cycle, like the seafood?
Not quite. It's more so Krebs with an E.
Oh, I see. So this is more of that science-y stuff than what you might find at, say, Nagoya.
Yeah.
Okay, go on then.
It's located in the mitochondrial matrix. Acetyl CoA enters a cycle of reactions, fully oxidizing the remaining carbon atoms to CO2. The product is ATP, NADH, and FADH2, which are more electron carriers.
Okay, so basically this whole process is about making energy for your body. It's very interesting. And you said there were 3 steps, so what is that last one?
The electron transport chain.
Okay, and what happens during that stage?
It is located in the inner mitochondrial membrane, and NADH and FADH2 donate high energy electrons which are passed down a series of proteins which release energy. And then oxygen accepts the used electrons and protons to form water.
Okay, that's very interesting. The process is a lot more complicated than I thought. So, could you maybe explain an example of this in effect, like a real-world application?
No.
That's a requirement for the project.
We'll do a jump cut.
No, just say like
what? No,
just say like jump.
Now, with all this information, do you think you could give me a real-life example?
Oh gosh, you're kind of putting me on the spot here, Blake. But from what I understand, if you were to say, go to a restaurant like Jimmy John's and eat a sandwich. Sorry about that, folks. If you were to go to Jimmy John's and eat a sandwich, the carbohydrates in the bread and the molecules in the rest of the food would break down into pyruvate and then travel through this process, eventually creating ATP to give you energy to feel better and be more active. Is that kind of the gist of it?
100%. A+.
Thank you. I feel like I've learned a lot from you today, and it's always great to talk about cellular respiration on Wyatt's Guide to Cellular Respiration. Catch you on next episode, folks. We'll be talking about cellular respiration.